Hello friends, you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. This channel provides basics of finite element analysis and computer-aided mechanical engineering design and analysis using CAD-related software. Let's get started.
Hello friends, today I'll show a very basic SolidWorks learning tutorial for the beginners. This is tutorial number 2nd. In this tutorial we'll show a very basic example like piston. This model will be done by making a profile and then finally it will be revolved along a central axis, right? We'll show this one by using SolidWorks software. Okay, then let's get started. Okay, next part you have to draw two arcs, starting arcs from this point. One arc is this one. Let's draw another arc from the same point. This is the second arc. Okay, let's provide a smart dimension to this one. It is 170 millimeter. Okay, done. Next one, the distance from here to here, you can see from the drawing I generating, it is 116 millimeter, the diameter, right? So we'll take smart dimension from here to here. It will be 116 millimeter. Okay, right. And again the distance from here to here is 7 millimeter. Okay, and again this part, you can see the diameter of this small part is equal to how much it is. It is showing equal to 66 millimeter dia. Done, right? Okay, fine. Now here some fins will be required actually, so we'll make some lines. This is 10 millimeter, then all are remaining are 5 millimeter itself. What we'll do is we'll make some lines, then we'll apply some relations. We'll provide some dimensions at the beginning level, and finally all will be having some relations and all will be equal. Okay, now let's provide dimension to these things. First one is having length 10 millimeter. Okay, next one, this is 5 millimeter. You can provide here itself 5 millimeter. Okay, now this one also 5 millimeter. Next to that, I will provide all those dimensions with relations. Make all these relations equal. Select this line. All lines are selected and that's relation equal to equal. Okay, so we got all the horizontal lines equal to 5 millimeter. Now we have to select vertical lines, right? Okay, select vertical lines again. Better to select all the lines of the same side. This one, this one, this one, this one, all are equal. Okay, right. Now the right hand side lines you have to make it equal. Okay, we'll make this one equal to all the remaining right hand side lines. The relation will be equal. Okay, done. So all we got all these lines, vertical and horizontal, all are equal to 5 millimeter, right? Okay, next one, what we have to do is we have to move down, moving down a little bit, then you have to move a little bit inside, by dragging you can select this part, right? Done. Next part is we have to make some dimensions from top to bottom. This length is given equal to 110 millimeter. Smart dimension selecting from top to this one equal to 110 millimeter, right? Okay, done. Next part is from here to here some dimensions are provided. You can see from this part to that was total 100 diameter, right? 100 diameter. So this one to this one equal to 100. Okay, this part equal to 30 millimeter. Done. So all others are complete. Now the remaining is this part you have to make it close. It should be a closed drawing, so you join this part together. Done. Now it is a closed drawing, right? So drawing is complete. Green check. And we have to exit from the sketch, right? Next part we have to select this object and that to be revolved with respect to the central line. So revolve was this with respect to the central line. This is the cylinder made, right? Now another thing is at the base we have to make a hole, right? We have to make a hole. So we have to know the location of the hole. Anywhere, any plant, it will be symmetric actually. Hole. If we make a hole, it will be symmetric. Now you know the diameter of this one equal to 116 millimeter. That means we have to make a plane with respect to the central plane. We have to make a plane 58 millimeter away, right? You see the plane. This is the front plane or right plane, any one. Let's take the right plane. With respect to right plane, we have to make another plane which is at the surface or at the periphery of this cylinder or piston. That means total diameter is 116 millimeter. Therefore, from this plane, it will be 58 millimeter away. Another plane is required. Okay, so we'll make a reference geometry plane. Okay, we made the plane. Green check. Plane is ready. Now we have to start drawing on that plane itself. The plane is there, the normal to that plane, right? Okay, now on this plane you have to make a hole, right? Initially you have to make a circle, that to be extrude cut. Okay, so starting on sketch, initially one center line is required to have the location of the circle. We'll make this as the center line. Again another center line is required to get the center point. Center line we're taking. Done. Now here at this point we have to draw the circle. This location is already given. Let's provide smart dimension to that one. This one equal 30 millimeter. Okay, done. So drawing is complete. Green check and exit from the sketch. Next part we have to select that sketch and features extrude cut, and we have to cut this one through all, right, up to body or through all, right? Okay, fine. So this is made, right? You can see the hole also. Okay, now another thing, so to have a better view we can do something. We can provide a like appearance to this piston. the appearance should be like some kind of metallic appearance will be required. And also that plane we can make it hidden, make the plane hidden, right? And we have to apply some appearance, metallic appearance. Let us apply steel. We got different grades of steel. Let's take polysteel. Okay, done. To have better view, we can change the background a little bit. Maybe it will be a little better, more bright. So we make the background little plain white. Okay, so this looks better, right? So this is a final drawing. Actually this is a very basic one. From this one we can understand a little bit of like cross-sectional area drawing and revolving with respect to the central axis. At the same time we can understand like creating reference geometry or reference planes, and we learned about extrude cut, etc., right? And we learned about little bit of providing relations. In this case, by providing relations we made all the fins equal values. Okay, this is all about our today's second tutorial. If you like the video, please subscribe and share, and if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again.